Let's have a look at question 4a. I'll do A, you guys can do B and C. Now it says here, 4, for each of the functions below, 1, find the derivative, 2, find the set of values of x for which the associated function is increasing. Okay, if it's increasing, it has a positive slope, so we're going to look for that. Okay, so let's get stuck into this. 4a, y equals 2x minus 1 and 3x plus 4. Let's expand that. We've got y equals 6x squared plus 8x minus 3x minus 4. Collecting like terms, 6x squared plus 5x minus 4. dy dx equals 12x plus 5. Now it says 1, find the derivative. We've done that. 2, okay, so part 2, find the set of values of x for which the associated function is increasing. It's increasing when the slope is, the derivative is greater than 0. So when this is greater than 0, so that would be, let's resolve this one. We've got 12x is greater than minus 5. X is greater than minus 5 on 12. So that should be true for when x is greater than minus 5 on 12. Would be where the function is increasing. Let's talk about this parabola. It's a regular concave up parabola. So it's a regular parabola. It has a minimum. Okay. Now the minimum, at the point of the minimum, to the right of the minimum, it would have a positive slope, and to the left, it would have a negative slope. So this point here would also be the vertex, the x value of the vertex, which would be minus b, which is minus 5, on 2a, which is 12. So that looks good. Now let's just put this into the calculator and see what the curve looks like. And it looks like this. Okay, so we can see that point there. That minus 5 on 12 would be minus 0.417. And you can see that's got a positive slope. That's got a positive slope. And that side has a negative slope. So that's why it's a vertex point as well. Okay. Another interesting feature now is I've actually plotted the derivative. Now the derivative is a straight line. You can see that's the red line here. When it's above y equals 0, so when it goes above the x-axis, that's when it's positive. And that's no coincidence that that point there, where it crosses the x-axis, is at minus 0.417, which is right above that point. Because when the derivative is positive, that's the red line, it'll be there, and there it's negative, so that shows the negative slope. So quite a good question to understand what's happening.